Check, check, check 1, 2. Oh, hey guys. Guess what? It's me, Mr. Pouts. All right, we're gonna go through this quiz. I'd like you to go ahead and follow along. Take note of the things that I write down. If you really want to learn from your mistakes, write down what I write down, and if you need to pause it to look at it, figure out what I just did, please do so. I'm gonna try to explain it as best I can, especially some of the common mistakes in this quiz. Because there's lots of different things to remember with exponents, so I want to make this as easy as possible for you. So this first section in the basics of exponents. 9 cubed really just means 9 times itself 3 times. Most people got this correct, but it also says solve if possible. So 9 times 9 to 9 would be part of it. That's also equal to 9 times 9, which is 81, times 9 again, which gets you, I believe, 729. Okay? Number 2, x to the 8th power is simply x times itself 8 times. So that's all I was looking for, is for you to expand that one to be x times x times x times x times x times x times x times... One more? Yes. All right, number 3. Number 3 was a common area of mistake. It says, give an example where the base is -1 and the result is a negative answer. So if we have an exponent, our base is -1, we need to find the exponent that would make it a negative answer. So let's take a look. If you made it a 2, let's just say. We've talked about this before, but if you made it 2, that just means -1 times -1. Well, that answer is +1. So in order to make it a negative, we have to multiply it by another -1. So let's make it to the 3rd power. Multiply it by -1 again, so that'd be 1 times -1, which would equal -1, because you have another negative. And the second part to this, so this would be a good example here. The second part says, explain how you would know if the result would be positive or negative if the base is -1. So for a base of -1, or any negative base, if you have an even number exponent, like 2, 4, 6, 8, it's always going to be a positive answer. Because 2 negatives are always going to cancel each other out to become a positive, and if you have 4, that's just doing it twice. Whereas an odd exponent is going to be a negative answer. So that would be how you could explain it in words. Let's go to section 2 now with some multiplying. All right, key thing in section 2 is multiplying the common things by each other. So what I'm going to do is 2 times 3 out in front. Those are our coefficients. Those always get multiplied together first. 2 times 3 is 6. Then I also have the x to the 5th and x squared. I put dots between them because it's still all multiplication. If you look right here.
Hey, Don, could you please come down to the front office and open one of the exterior doors? We have some basketball players coming in to use the gym. Thank you.
Did you just hear that? That was Mr. Wachowski on the announcements. Anyway, moving on. We're still multiplying them, but we can move around multiplication because it's a property. We can multiply them in different orders if it's all multiplication. So we just move it around so it's things that we like. 2 times 3 is 6. X to the 5th power times x squared is x to the 7th power. We add those exponents. It's like we have 5 of them here and we have 2 of them there. If you expanded it the whole way, we'd have a total of 7, which would be x to the 7th power. So let's do that with the rest of at least these first 3. A squared times a to the 3rd power, we would add the exponents and it would be a to the 5th power. Not much work to be shown there. Number 6, let's rearrange it. Let's do this 3 times 4 in front. We can do the x's next. X squared and x to the -2nd power. And we have the y's. Y cubed and y squared. So let's do them in order. 3 times 4. X squared times x to the -2nd, and y cubed times y squared. 3 times 4 is 12. X to the 0 power, if we add them up, 2 plus negative 2, and then y to the 5th power. And hopefully you recall that x to the 0 power is just 1. So it'd be like doing 12 times 1 times y to the 5th power, which is just 12 y to the 5th power. Okay, you didn't have to write that all out, but just understanding that that was 1, so it goes away. 7 and 8, we've got something else going on here in number 7 and 8. We have exponents outside of the parentheses. So I'm going to use red here. If there's an exponent on the outside, we take it and we distribute it to all of the parts of the inside, all of the different bases. So x to the first power, we do that 1 times the 4. So it'd be x to the 4th power. For the y, we do the exponent of 3 times 4, so it'd be y to the 12th power. And that is our simplified result. Number 8, we've got more going on, but we have to just do it as we've learned it so far. We've got an exponent here that goes to the x and to the 2, and we have an exponent here that goes to the x squared and to the 3. So if I rearrange that, it's 3 cubed times x, 2 times 3 is 6, times 2 cubed times x cubed. 3 cubed is actually 27, so I'm going to rewrite that as 27. And I'm going to bring this down here as well and do the 2 coefficients first. 2 cubed is 8. All right. Then I'm going to take our x's and bring those down here next to each other and make it so that we have x to the 6th power and x cubed by each other. And now if I look at the things that are alike, I can multiply those together. So 27 times 8, I got 216. And x to the 6th power times x cubed, we've got 6 and we've got 3, that makes 9. So it's x to the 9th power. And there's our result for number 8. That's the gist of what multiplying exponents is all about. Section 3 gets us into some division. Now for division, especially in numbers 9 and 10, we still want to do it in parts, kind of like we did up above. But if it's dealing with exponents, it would be, instead of adding, it'd be subtracting because we can cancel them out. So think about it like this. If you have x to the 4th power over x to the 4th power, they're the same on top and bottom. They cancel each other out. And it really would just be 1. Same idea goes here. Let's look at number 9. And let's break it apart. We've got the 6 divided by 3. And I'm going to even stretch it out like this. X to the 7th over x to the 4th power. If we just look at the 6 divided by 3, we know that's 2, or 2 over 1. And the x over to the 7th power over x to the 4th power. So with the x to the 7th power over x to the 4th power, it's like we're writing it out as x times x times x times x times x. So 7 x's, I have missing one, multiplied together, and then there's 4 on the bottom. And think about it like this. Anytime you have an x over x, it cancels it out. Like 4 over 4 is just 1. It just cancels each other out. So we're canceling 4 out on the top and the bottom. There's just 3 left on top. So you can look at it like this too. Nothing left on the bottom. Get rid of this and it's just x to the 3rd. So 3 of them left on top. So our answer, our final result, 2 on the left and then x to the 3rd power. And there's nothing on the bottom anymore because they were canceled out that way. 2x to the 3rd power. Let's do a similar thing in number 10. If we visualize it this way, 5 a's on the top, 3 on the bottom. 3 cancel out on the bottom, and 3 cancel out on the top. And you're left with 2 on the top. So 5, the other way you can look at it is a to the 5 minus 2. B's, we have 8 on the bottom and 10 on top, so we can cancel out 8 on the bottom and 8 on the top, and you're left with 2 left on the top. 8 minus 2, 10 minus 8 is 2. So you end up with just a squared, b squared, nothing on the bottom. Last one from this one, it actually has something on the outside of the parentheses, which my encouragement to you is always to try to get rid of parentheses right away. So when you're distributing, we didn't do it up in number 7 and 8 because there wasn't a denominator, but we still have to distribute to the denominator. So you distribute to every part. So in this case, it would be written as 3 to the 12 times 2 is 24 over 3 to the 8 times 2 is 16th power, which is gets rid of the parentheses, and that's great. There's still some simplifying to do, though. There's 16 on the top, bottom, and 24 on the top, so 16 can be canceled out on both top and bottom, and you're left with this 3, 24 minus 16 is 8. So you're just left with 3 to the 8th power, or I believe that answer is not terribly large. It's 6,561. 6,561. All right, let's go to page 2. Page 2 starts off with negative and 0 exponents. So big rule with the 0 exponent, it just becomes 1 if it's something with a 0 exponent. Negative exponents, you got to move it. If it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. You just got to move it to make it a positive. So in this case, it's essentially x to the negative 7th power over 1. So let's move it to the bottom. So we have x to the positive 7th power on the bottom. And if there's nothing else there, you put 1 on the top. So it's 1 over x to the 7th power. Number 13. Excuse me. We know anything to the 0 power is 1. So hey, let's make this a 1. That's it. There's a negative exponent, though, right here. To make it a positive, we move it. It's already in the basement, so let's move it up. So it's to the top. So r to the 2nd power is on top. M to the 3rd power is on the bottom. Nothing else can be simplified. That's all you had to do. We have all positive exponents. There's nothing else you can cancel out. Number 14, the easiest question on the quiz. Well, it's all in parentheses. It's all raised to the 0 power, so it's equal to 1. Anything to the 0 power equals 1. There you go. You don't even have to distribute because you know it's all raised to the 0 power. Let's go to section 5, a mixed variety of examples. In number 15, there's a lot going on, but I see parentheses, and with parentheses we need to distribute the exponent. One thing with this is it only distributes the stuff in the parentheses, all 3 parts, not to the bottom, because the bottom is not in the parentheses. There's no parentheses around the denominator. So I'm going to rewrite this as 2 to the 3rd power, x to the 3rd power, and y to the 5 times 3 is 15th power. Okay? On the bottom, on the denominator, I have 2, which would be to the 1st power if you want to write it that way. X cubed, y to the 8th power. Now with this, that's our first step. Our second step would be to simplify anything you can simplify. So let's look at the top and the bottom. I see a 2 base to the 1st power, so 1 can cancel out here, 1 can cancel out here, so you're left with 2 squared. Just 2 left up there. X's, we've got 3 on top, 3 on bottom. They're all gone. Same thing on top and bottom will cancel out. And the Y's, I've got 15 on top, 8 on the bottom, so I'm going to cancel out 8 from both. And 15 minus 8 is 7. So there's nothing left on the denominator. 2 squared is 4. I'll write that out. It's 2 squared. All we're left with is 2 squared times y squared. Or, sorry, y to the 7th power. Which equals 4y to the 7th power, because 2 squared can become 4. And that is fully simplified. Number 16, we've got lots of parentheses. So let's work our way inside out. Generally, that's what we want to do, is work inside out. These two can be multiplied together to get 3 to the 20th power. And that's all squared. Same thing goes here. I can do the 2 times the 20, and I get 3 to the 40th power, which I am not going to write out the whole answer because it's going to be longer than this sheet of paper. Don't want to do that. Let's go to number 17. Number 17, lots of things can cancel out. I want to start with the 9 over 27, and I'm going to pull it out here just because to show you that it's a fraction. It's a fraction on 9 over 27. Okay? We can simplify that, just like you reduce fractions. Find something you can divide them both by. You could divide them both by 3, but you could also divide them both by 9. And you get 1 over 3. So what I'm going to do here is I'm going to take this. I'm going to take this. I'm going to make it smaller because that's not the main thing here. I just wanted to show you how you can reduce that. It's up here. So when we reduce the 9 over 27 part, it's like you're dividing them both by 9, you get 1 over 3. Okay? Let's work with the x's. I can cancel out 2. There's a 5 and a 2, so cancel out 2 from each side, top and bottom. 5 minus 2 would be 3. So x cubed is on top. Y's, there's 1 on top, 6 on the bottom. Let's cancel out 1 from the top and the bottom. 1 is gone there. So I'm left with y to the 5th power on the bottom. And then z's, I can cancel out 3 on the bottom and 3 on the top. So I'm left with just 3 on the top. So z to the 3rd power. And that is fully simplified. There's nothing else to do. Last question, number 18. We've got parentheses. So I'm going to encourage you to do the parentheses, or get rid of that parentheses. So I'm going to distribute to every single part, top and bottom. So I would have 4 squared m to the 4th power, 2 times 2 is 4, n to the 6th power over 5 squared, m to the 12th power, n to the 8th power. Now, when I rewrite this so I can cancel things out, let's first start with this 4 squared and 5 squared. They're not the same base, so you can't actually simplify those. But let's see what they equal. 4 squared is 16. 5 squared is 25. All right, let's look at the m's. I've got 4 on top, 12 on the bottom, so 4 can cancel out on both the top and the bottom. And I'm left with 12 minus 4, which is 8. So m to the 8th power on the bottom. N's, I've got 6 on top, 8 on bottom, so get rid of 6 there, get rid of 6 here, and I'm just left with 2. So n to the 2nd power, n squared. That is fully simplified, and the reason is because 16 over 25 you can't reduce. So all of what we did, you can put into some steps. I would say you always want to look for distributing first. Distribute exponents outside of parentheses. If you have to. Next, I would always look for like negative and 0 exponents. Simplify those. Simplify negative or 0 exponents. Simplify. I can't even spell here. So negative exponents by moving them to the bottom, or to the top if it's already on the bottom. And 0 exponents by essentially getting rid of them or changing them to a 1. After you do that, I would look on top or bottom and combine, which would be like, you know, multiplying them or combining. Before you cancel out. Cancel things out, which would be simplifying division. So all you can do is really those 4 things. The order is not necessarily crucial, but that's my suggested order for you. And that's this quiz. That's all the different properties of exponents. I know it's a lot, and there's lots of different types of examples, but that's why we're doing so many different examples, to try to get you to feel more comfortable doing it. All right? That's that. Have a wonderful rest of your day.